bridge, and we're trying. For this problem, we're given the equation of a line that's talking about a support beam on the Jefferson Street Bridge, and we're trying to figure out the equation of a perpendicular brace that is perpendicular to the support beam and is passing through the point -8,3. So this is essentially the same problem as problem 3. It's actually a little bit easier though because we don't have to solve for y, it's already in slope-intercept form. So here's my equation, y equals 2x minus 5, and what I want to do here is figure out the slope. So I'm looking for the number next to x, which is 2. So the slope of the line that we're given is 2. However, when you look at the problem, it's asking us for a perpendicular line. So I'm not going to use the slope of 2, that's what I would use if it was parallel. So the perpendicular slope would be the opposite reciprocal of 2. If it helps, you can write this as 2 over 1, and that way you can see it as a fraction. The reciprocal would be 1 over 2, and then since my blue slope is positive, my opposite reciprocal would need to be negative. Now I have a point here, -8,3. That's going to be the x and the y that I plug into slope-intercept form. So over here, here's slope-intercept form. And what I'm going to do is take x and y and my new perpendicular slope and plug this in to solve for b. So my point for y is 3, and that equals slope, which is -1/2, times my x value, which is -8, and then I have plus b, and b is what I'm trying to solve for. So now I need to simplify -1/2 times -8. That comes out to be 4. And it's positive 4 since it's a negative times a negative. And now I'm going to be subtracting 4 from both sides, so I get that b is equal to -1. So now I need to take the two pieces of information that I have here, so my perpendicular slope and now the b value that I just got, and plug it back into slope-intercept form. So now I would have y equals -1/2 x minus 1 for my final answer.